Hey guys, if you need help with a chapter review, chapter 5 review, chapter 8 review for the Pythagorean theorem, I'm going to do number 5 and number 7. So on number 5, let me angle it. We've got this two right triangles. This first one has a height of 12 and a hypotenuse of 20, and then the other one is on the right, but we don't know a lot of things about that, just that this height is 12. So what I'm going to start with is finding this length right here. I'm going to call it x. So we have a height of 12 and a Pythagorean, or a hypotenuse of 20, so I'm going to use the Pythagorean theorem. I'm going to take 20 squared, that's my c, equals x squared plus 12 squared. A squared plus b squared equals c squared. That means I'm going to subtract over my 12 squared. 20 squared minus 12 squared equals x squared. And if you type this in, you'll get 256. So 256 equals x squared, and then the square root of 256 is 16. So this length right here is 16. And then I can start to work on the second triangle. This whole length is 24 and this piece is 16. Obviously it's not drawn to scale, but 24 minus 16 is 8. And then we have 8 and 12. And so now I can find the hypotenuse of the other triangle. 12 squared plus 8 squared equals c squared. We'll call this guy c. So I end up getting 144 plus 64 gives me 208. And then we can take the square root of that, and that would be c. Now you can, if you want, simplify this farther into the radicals. 208 divides by 16. 16 times 13. And because 16 is a perfect square, the square root of 16 is 4. It comes out in front. So 4 square root of 13 is the length right here of c. And the other one I was asked to show is number 7. Okay, so 7 is a similar one. It has some right triangles here because this is a rectangle. This is not drawn the same way that it is, but we've got 2 and 4 here. We're asked to find AR and AS. This is 10, and this whole thing is 12. Okay, so I don't think this 10 is given, but these are two right triangles here in the corner. The first one, we've got 2 by 4. Obviously, it's not drawn to scale, but if I want to find AR, let's call it x. 2 squared plus 4 squared equals x squared. So we've got 4 and 16. This is 20. So this length is the square root of 20. If I was to simplify that into perfect squares, 4 divides into 20. So I have the square root of 4 times 5. And just a reminder that the square root of 4 is 2. So the 2 comes out, 2 square root 5 is how I got my final answer for AR. You see that? 2 square root 5. And then the next one, I can find this length up here. If this entire base is 12 and this piece is 2, then this piece must be 12 minus 2, which is 10. And then on the other side, I've got a length of 4. If this right side is 4, then so is the left side. So I'm going to do Pythagorean theorem again, and I'm going to find, let's call it y. I don't know why we switch colors here. Let's call it y. So I have 4 squared plus 10 squared equals y squared. 4 squared plus 10 squared is 16 plus 100, so I get the square root of 116. Is y? Well, I went a step ahead. Y squared would be 116, so the square root of 116 would be y. And then 4 divides into this. It's the largest perfect square, so this is 4 times square root. Sorry, let me erase this. It's the square root of 4 times 29, and 4 is perfect, so 2 comes out because the square root of 4 is 2. So that is our y. So these are our two answers here. Okay.